Hi, this is Albert Nixon, Assistant Professor, Department of Chemistry, St.Joseph's College of Arts and Science, Autonomous, Cuddalore. In this video, we are going to discuss about column chromatography. These are the contents we are going to discuss: principle of column chromatography, practical requirements, factors affecting column efficiency, applications of column chromatography, advantages and disadvantages, partition column chromatography. So, historical background of column chromatography. This chromatography was first developed by Swift in the year of 1906. In all the early applications, the procedure was limited to the separation of colored substances. Hence, it named as chromatography. He developed the technique. He coined chromatography in the first decade of the 20th century, primarily for the separation of plant pigments such as chlorophyll, carotenes and xanthophylls. Since these components separate in bands of different colors like green, orange, yellow and respectively, they directly inspired the name of the technique. New types of chromatography developed during 1930 and 1940 made the technique useful many separation process. Chromatography is a laboratory technique for the separation of mixtures. The mixture is dissolved in a fluid called mobile phase, which carries through the structure holding another material called stationary phase. When chromatography carried out in a column is called column chromatography, or otherwise called gravity chromatography. Some chromatographic terms: analyte. Analyte is nothing but the substance to be separated during chromatography. It is also namely what is needed from the mixture. Next one is analytical chromatography. The use of chromatography to determine the existence and possibly also concentration of the analytes in a sample. Bonded phase. A stationary phase that is covalently bonded to the support particle or to the inside wall of the column tubing. Chromatogram. The visual output of the chromatograph in the case of optimal separations, different peaks or patterns on the chromatogram compressed to different components of the separated mixture. Chromatography, a physical method of separation that distributes components to separate between two phases. One is stationary phase, another one is mobile phase. Eluent, the solvent or solvent mixture used to elution chromatography, and the synonyms with the mobile phase. Elute, the mixture of solute and solvent exciting the column. Effluent, the stream flowing out of chromatographic column. In practice, it is used synonymously with elute, but the term more precisely refer to the stream independent of separation is taking place. Solute, the sample components in a partition chromatography. Solvent, any substances capable to solubilizing another substance, and especially the liquid mobile phase in liquid chromatography. Next one is stationary phase. Stationary phase is a standard phase. It is nothing but silica gel. Then finally, detectors, the instrument used for qualitative and quantitative detection of analytes after separation. Types of chromatography. So these are the various types of chromatography: planar chromatography, paper chromatography, thin layer chromatography, it is simply called as TLC, the gas chromatography, liquid chromatography, supercritical fluid chromatography. Types of column chromatography. So column chromatography further subdivided into 4 types. One is adsorption chromatography, partition chromatography, ion exchange chromatography, and gel chromatography. Some terminologies are involved in column chromatography. Stationary phase, it is also called as adsorbent, it is a solid. Then mobile phase is nothing but moving phase is mobile phase. Then sample, it is also known as adsorbate, which get adsorbs. Then elution, dilute, these are we already discussed. Adsorption chromatography, it is a surface phenomenon when the stationary phase in a solid and the mobile phase is a liquid or gas. It is known as adsorption chromatography. Principle of column chromatography, when a mixture of components dissolved in the mobile phase, or it is nothing but liquid phase, is introduced into the column, the individual components move with different rates or different polarities upon their relative affinities. The compound with lesser affinity towards stationary phase move faster and it's eluted out of the column first, and then one by one, then second one and third one and fourth one and fifth one, and moves on. This is a basic principle of column chromatography. It is one of the important separation technique. So here I shown 3 different columns. The first column is containing, it's like a burette like setup, right? The cotton wool and stationary phase. Stationary phase is nothing but silica gel, and our mixture of components, right? Here we take A plus P plus C. There are 3 mixture of components are there. Then finally solvent. So solvent. Then after 1 or 2 hour we are running the column. The result will be the separated bands. So here the second one is A is different ratio and B plus C in the different ratio. Then finally into A and B plus C and C. So it's a complete process of column. Then the rate of movement of component RF is given by rate of movement of a compound divided by the rate of movement of the mobile phase. So mobile phase is a moving phase. Some ideal properties of stationary phase. Particle should have uniform size and spherical shape. The size should be 60 to 200 mesh. That the particle size, the silica gel size. They should have high mechanical stability, inert and insoluble to mobile phase. We take silica gel as a stationary phase. It should not be insoluble one. So it should be a insoluble one. And the next one is colorless and odorless. Should allow free flow the mobile phase, freely available and inexpensive. So it is a low cost material. And some properties of mobile phase: to introduce the mixture into column as solvent, to develop the zones for the separations for developing agent, to remove pure component out of the column as eluent. Different mobile phases were used like petroleum ether, cyclohexane, ethers, chloroforms, water, organic acids, and carbon tetrachlorides, carbon disulfides, acetone, alcohols, and pyridines. These are the various mobile phases were used depending upon the compound nature. Next, column characteristics. Column material is made up of good quality and a neutral glass, since it should be not be affected by the solvent and acids and other alkalis. Right? The column material should be a good quality material, so it should not affected by the solvents and other acids. Column dimensions are important for effective separations, so we should careful while running the column. The dimensions is very important. So the length and the diameter 10:1 ratio and 30:1 ratio. For more efficient separations, the diameter length is 100:1. Importance of packing of column. The column must be packed as uniformly as possible to minimize the distortion of the chromatographic boundaries. Channeling is usually caused by incursion of air bubbles during the column package. There are types of package. One is dry packing, another one is wet packing. So in wet packing, this is the ideal technique. The slurry of absorbent with the mobile phase is prepared and poured into the column. The stationary phase settle uniformly in the column, and there is no entrapment of air bubbles. There will be not be any crack in this column absorbent. So these are the dry packing and wet packing. Then finally detectors. The detection of colored components can be done visually. Different colored bands are seen moving down the column, which can be collected separately. But for the colorless components, the technique depends upon the properties of the components and monitoring by the TLC. And finally, recovering of components. The best technique is to recover the components by the process are called elutions. The components are called as elutes, the solvent called as eluent, and the process removing the components from the column are called elutions. The factors affecting column efficiency. These are the factors highly affected the efficiency of the column. The first one is dimensions of column. Second one is particle size of the adsorbent. Then third one is nature of the solvent. Then fourth one is temperature of the column, and the fifth one is pressure. Applications of column chromatography. It has some vast applications. The first application is separation of mixture of compounds, removal of impurities or purification process, isolation of active constituents, isolation of metabolites from the biological fluids, estimation of drug in formulation or crude extracts. Any type of mixture can be separated by the column chromatography. Any quantity of mixture can also separated. Wider choices of mobile phase. We have lot of mobile phases are there, like petroleum ether, cyclohexane, ethers, chloroform, water, organic acids, carbon tetrachlorides, carbon disulfides, acetone, alcohol, and pyridine. There are wider choices of mobile phase. In preparative type, the sample can be separated and rescued. Automation is available or possible, and also some disadvantages are there. So time consuming method. So we cannot say it is an 1 hour column, it is an 2 hour column. So time consuming is an biggest disadvantages. More amount of solvents are required, which are expensive. Automation makes the technique more complicated and expensive. So automation is very difficult in column chromatography. So these are the reference book. Thank you for your patient listening.